Welcome friends, once again. Recently in previous video we learned the introduction part of geometric sequence. Now here is a question related to the introduction of the geometric sequence. Check the following sequences are geometric sequence or not. If yes, find the common ratio. Okay, and here are the three questions for three sequences we have got here: first one, second one, and the third one. And now we need to check whether they are geometric sequence or not. And in previous video we talked that to be a geometric sequence, the ratio of the succeeding term and the preceding term must be constant, right? I mean to say the ratio of the must be constant, and that constant is called common ratio, right? If this is applicable throughout the sequence, then that sequence we can say is a geometric sequence. If not, then we can't say that that's a geometric sequence. So let's check in every one by one whether they have the constant ratio throughout the sequence or not. Okay, so let's do our operation for the first sequence. Our first sequence is 4 minus 2 1 comma minus half and so on, right? So here let me find out the first common ratio by taking the second term over the first term, right? So that's why I'm writing this R1, right? Here all the common ratios should be equal. I mean, if I'm going to find out the R1, R2, R3, these all should be equal. So let me first find out R1. And the formula of the R1, or simply you can say the common ratio, is a ratio of the succeeding term over the preceding term. Okay, so succeeding term here I'm taking minus 2, and the preceding term will be 4. Okay, so minus 2 over the 4, that is second term over the first term, that will be my minus half, right? Because 2 times 2 times 1 2, right? So it's minus half. Let me take one more, R2, right? So here I'm taking R2. I can take any number. Suppose I'm taking the fourth one and the second one, because fourth one is the succeeding of the preceding term, third term, right? So you can say the fourth term over the third term, that is minus half over the 1, and that's again minus half. That's a good news. Again we got the common ratio same. Okay, let's find out one more, third common ratio. Let me find out third common ratio. Here we can take any one. Let me take the third term over the second term, right? The succeeding, this sequence is a geometric sequence, right? So I is a geometric sequence or geometric progression, whatever you say. All right, so now let's talk about the second one. Okay, here second one is let me do here, let me write the first what we have. It's minus 2 by 3, that's our first term, minus 6 is our second term, minus 54 is our third term, and so on, it's going on. So again let me find out the first common ratio, right, by taking the second and the first. So it will be the succeeding term over the preceding term. Okay, and here my succeeding term is minus 6 and my preceding term is minus 2 by 3, right? So this 3 will goes upside, and this minus and minus will cancel out, and it will be 6 times 3 over 2. So 2 times 3, right, equals to again 6. So 3 times 3, that is 9. So I got the first common ratio from by taking the first term and second term. It's 9, right? Now let me take another one, the third one and the second one. So my second common ratio, right, that's third term over the second term, and my here third term is minus 54 and my second term is here minus 6. So again what can I say? Yes, that minus and minus will cancel out, and 6 times 9 is 54. So we got 9 again. So here again what we got? We get here the first common ratio and the second common ratio both are equal, right? First common ratio is equals to second common ratio. It means this is again a geometric sequence because the common ratio is constant throughout the sequence. Alright, now let's talk about this third one. Here see, minus 1, 5 by 6, 2 by 3, minus 1 by 2, like this. It's a sequence, right? So let me first find out the first common ratio, right? R1, that's again same, the succeeding term over the preceding term. succeeding term here a2 is 5 over 6 and preceding term is here minus 1, so it is overall I will get minus 5 over 6. That's my first common ratio. Alright, so let me take out now my second common ratio. Okay, here my second common ratio will be again the third term over the second term, and my third term here is my third term is 2 over 3, right? 2 over 3 whole divided by 5 over 6, 5 over 6. So now see, it will be something like 2 over 3 times this 6 will go upside, so 6 over 5. Now 3 times 2, that is 6, so 2 times 2, that is 4 over 5. Oh my god, that's a bad news for us. See here, the first common ratio is 5 over 6, negative 5 over 6, and second common ratio is 4 over 5. They are different. So since R1 is not equals to R2, it means common ratio, first common ratio is not equal with second common ratio. It simply tells us that the common ratio is not equal throughout the sequence, means this is not a geometric sequence. Alright, so I hope that from this illustration you understand how to check whether that's geometric sequence or not. Right, simply what you have to do, see the succeeding term over the preceding term is constant all out throughout this sequence or not. Any sequence whatever you are getting in your question, if that's constant throughout the sequence, if it's constant, then that's a geometric sequence, otherwise it's not a geometric sequence. Okay, it may be a harmonic sequence, it may be a simple arithmetic sequence, or it may not be a sequence, right? It may be anything. So just confirm whether the succeeding term over the preceding term is always constant or not. Okay, and here the question is saying if yes, find the common ratio. Actually these are the common ratio, right? Whatever we have find out here, this minus half is common ratio of this first sequence, and here